This is the second session with Juan Velasco of 5W Infographics. And this is a session in our relevant research series that is hosted by the Sherman Center for Digital Scholarship and the Spark, a Center for Social Research Innovation here at McMaster with funding from the Social Science Research Council. I'm Michelle Dion, the Academic Director of Spark and an Associate Professor in Political Science. And without further ado, I'll just hand it over to Juan. Thank you.
Thank you so much. Thank you. Good morning, everyone. Welcome back. Thank you for coming back, or for those of you who are new, welcome to this second session. Remember, we discussed some principles of data visualization, and not only data visualization, but infographics, not just charts, but different ways of that we can use to communicate visually, to communicate those important messages from our organizations to a large audience, to the public. So this is day two, second session. And I'm going to, if you remember, when we finished last Friday, I was going to start mentioning some principles of design that apply to data visualization and infographics. And those two terms are very much mixed together in my mind. It's just ways of communicating information, not only numbers, but all kinds of relevant information for the public. So this will be like kind of a top 10. First, principles of design use the most sophisticated tool in data visualization, and that is the pencil. And that means we need to do those hand sketches before starting working on any kind of computer program. Those quick, fast computer handmade sketches is what really enable us to think through the information. What are the quick ideas we can have? The moment you commit to a computer application, the processes slow down and the ideas don't flow as freely. So in the back of a napkin, in a notepad, just those little handmade sketches are very, very useful to help you think through the information. So that's a critical part in my opinion. Speaking, for example, about dashboards and data visualization, something very practical to do from the very beginning is what we call a wireframe. A wireframe is kind of a modular way of thinking out how you're going to represent all that information so that you have some visual variety in that composition. So we distribute spaces, we create different hierarchy levels, we make sure there is a visual variety, a pace, and also we make sure we account for text. Sometimes when we sketch visualizations by hand, we tend to sketch only what is going to be visual, and we forget to sketch appropriate space for where the text is going to be. And it's always a mix of text and images, so always account for that space for text. So a wireframe is basically a sketch to allow you to distribute your elements in the page and to find a pace and visual hierarchy. Number two, we need to always define a clear reading order. And surprisingly, many people get this wrong, and they make confusing compositions. First, obviously, the headline on the top left. It's very critical always to have that introduction, to set up your graphic with a little paragraph that is going to tell us what the graphic is about. It sets up the story. It's sometimes very difficult when we go directly from headline to data points. So always introduce your subject, and then you can have a large image or a sequence, like in this case, and secondary information. It's a very, very simple reading order that applies to any kind of visualization or infographic. And for both data visualization and infographics, a good idea sometimes to avoid confusion is to create a very vertical or very horizontal layout in a way that forces your eye in only one direction. And that always works with charts, with infographics. It's very easy to read, as opposed to stacking rows and columns of elements. When you do that, these elements start competing with each other for attention in the page. So try to make something that is a bit more linear whenever possible. That's not so much of a problem online. Online, in most cases, you are just going to scroll vertically. So that problem of having multiple elements stacked both horizontally and vertically tends to dissipate. It's more of a vertical scrolling that makes things linear and very, very simple. We need to define a visual hierarchy. That means more often than not a very strong dominant element and very simple secondary element is what is going to work best. For example, you see that infographic on the left side, that's by the South China Morning Post about these very cramped apartment buildings in Hong Kong. Very dominant visual illustration that is going to engage the attention of the reader very quickly. It's going to call the visual attention. And then secondary elements that are going to add comparison, context, etc. As a design that tends to work very well, not only with infographics, but with any kind of data visualization, dashboards, like the one you see on the top. So think, what is your bet? What is your most important part of the graphic, and make that larger. A tip will be, after you finish your infographic, you can take that larger element and make it even larger, and take the small ones and make them even smaller, so that you establish a very clear hierarchy. You want to call attention. You don't want many elements of similar sizes in a page because they do start competing with each other for attention. However, there is an idea that also works and contradicts the idea of a dominant element, and that's the small multiples. That's when you have a lot of little elements of the same size. For example, this is an evolution of the design of Ferrari Formula One cars. Everything is the same size. There's no particular reason for any of them to be larger. Small multiples is another idea to show information in a way that can be engaging. You can see that idea apply even to an illustrated infographic there. That's a historical timeline of Hong Kong, beautifully illustrated. And the small multiples are also critical to display charts and data maps. For example, it's nearly impossible to show change over time in one map. So that idea always applies very well to maps when we need to show different moments in time. Think of that. Time shown on maps that typically you will have to do that idea of small multiples. And it's also a way of uncluttering data. Remember how I mentioned the first day that when you have, for example, a line graph that contains 6 or 7 lines, there is a lot of potential for confusion, too many lines crossing each other. But with that idea of small multiples, you can unclutter the design and they still remain comparable because they're on the same vertical scale. Color. Color is information, it's not decoration. So we need to use color strategically. And I think that the idea that works best is to use color with a lot of moderation, and only when you want to highlight something you really want to call attention to. For example, if you look at these numbers, I can ask you, how many 7s do you see here? How many number 7? It takes a while. You have to start looking at this. But just by using color, this becomes apparent immediately. So color, the power of color is to bring forward those elements that are important, and the rest should remain very muted or even gray, black and white. Look at these nice examples of graphics and data visualization where everything is black and white, gray, or very muted, and only what is important is highlighted. For example, in the first case on top, there is a red dot whenever a new home run record in baseball in the US was beaten. And then you can see, for example, the location of protests in Hong Kong, or a reconstruction of a shooting event in Spain. Color in all these cases makes whatever we want to focus attention on very, very immediately apparent. Imagine this illustration in the back was full color. It will be very hard to find the action. So the use of color should be very restrained. There is a very good tip from Nigel Holmes. He's a famous infographics designer. He says, you can finish your graphic entirely in black and white, and then only then start thinking about where some color can help bring attention. For example, that's a nice wordless graphic showing how many people greet each other with kisses in different countries. This is what doesn't work. I was starting to do consulting for an organization, and this is what I encountered. For example, very, very intense color backgrounds in a way that you basically don't know where to look at. Everything is very powerful, everything is bold and colorful, and that creates a lot of visual confusion. It's very hard to find what is relevant, what is really important in each of these graphics. I think by default, the background of an infographic or data visualization should be white or very light gray, almost no color. If you have a strong color in a background, you are also reducing the possibilities of having contrast, right? If your lightest color is already not white, you are limited to a small range of colors darker than that to establish any kind of contrast. And that should be typified. It's always a good idea if you're going to produce a good number of charts and graphics to have a style guide that establishes what are the colors you're going to use all the time. And typically that will be a short color palette, maybe 5 or 6 or 8 colors, no more than that, so that you keep a consistent visual identity. And for example, on the right side, that's a style book I did for an organization. The blues are the colors used for different combinations in charts. And then the red and yellow are emphasis colors. That means whenever there is something very important in a pie chart or a particular bar in a bar graph that needs to be highlighted, we use one of those. And that's it. It's a very, very simple and restrained use of color that I think it works best. This is what doesn't work. When you have a color key, for example, with 16 or 17 or 20 different colors, it's impossible to find differences between these many different color tones. So, for example, how to distinguish all these different shades of blue in Europe is almost impossible. So a color key should have no more than maybe 5 or 6 different colors. So a change in color ideally should correspond to a change in information or type of information. For example, that's a nice chart ranking the largest companies in the world through several years. What you can see here is the use of color is applied in a smart way. Red bands are Japanese companies, blue bands are American companies, and green are European. So in just a very quick snapshot, we can see the major trend, which is Japanese companies are going down, American companies are going up. So color is information. It separates categories in a way that makes that separation relevant for the content of the graphic. A change in color should be correspond to a change in type of information. And color can be applied in different ways. Color can mean a qualitative value, like to separate categories or entities that are different, but also it can take a quantitative value. The intensity and the shade of the color basically can indicate a number, like in that heat map at the bottom left, or that choropleth map on the right. The color is information by coding for numbers. The higher the number, the more intense the color. And that's how we build many of those data maps. For example, those election maps of different countries by colorizing regions in different intensities. You may have seen a lot of these kind of guides about the emotional attachments or feelings attached to colors. I would say forget about that, especially in terms of data visualization and graphics. That's meaningless. I mean, there are many cultures with very different perceptions of colors and many different contexts. And the red color can be very negative in the context of financial graphics. It means negative numbers. At the same time, it's a very positive color in Chinese culture. So it's all intermingled, and it doesn't make sense to think that way when we apply color to graphics. Just think about the chart itself and how to highlight what is important. So in general, for simple charts, you can use one muted color for all the parts of a graph. For example, you have a simple bar graph. There's no reason those bars are different from each other in color, and they can be all the same. And then if you need to highlight one, you can use some brighter color. And those are some ideas, some strategies. For example, for a pie chart, all the slices in the same color. I think that's nice and elegant. Or you can use shades of the same color, colors in the same family, or you can just highlight one with a brighter color. If you have a rainbow of very different colors, at the end people are confused. People stop attaching any meaning to the way you use color. Some people have trouble coming up with nice color palettes, but there is a lot of help out there. For example, that's a nice place where you can find different ways of creating color palettes. It's coloradobe.com, and you can look at monochromatic palettes, complementary colors, and it's very intuitive as a way to find nice looking color palettes. Number 5, yes.
Juan, can I ask you a question about color before you move on?
Yeah.
So I was struck, I'm thinking about particularly the slide that has the map of the globe with the many different colored dots. So what do you do if you have a figure or a chart where you have more than 5 categories? And you would like them to be different colors in some way? Like what would be the way that if you have kind of a some sort of line chart or graphic or something where you have more than 5 categories, so you would be kind of have the impulse to do more than 5 colors, is that a sign that you need to break it into 2 figures, or kind of how would you approach that if you know that you have more than kind of the recommended number of categories and you want to somehow kind of distinguish them?
Yeah, you probably need to rethink how you apply those colors. You can, for example, in this particular case, they could have combined this into a small number of, or create groupings to have less colors. Or we can always apply that idea of the small multiples. For example, this could become 3 or 4 different maps. The idea is that at the end you have to resolve this complexity problem. The idea of small multiples works combining categories, or maybe you have to go back to that pencil and rethink how you are going to show this information. Or maybe you can create just 4 or 5 categories here and then have a separate chart showing the breakdown. But this doesn't work, obviously, because it's very hard to distinguish shades. Yeah.
Thank you.
So use a grid, look for alignments. We need to find order in graphics. In particular, when we have large data visualizations or graphics, we need to create an internal grid. For example, that's a large poster I did about the Forbidden City in Beijing. The very first thing I do for all kind of infographics is this: I create a grid with multiple columns, and then I try to align as many things as possible to this grid to create an internal order. Otherwise, it will start looking chaotic very quickly. For example, you see the text blocks at the bottom, they are all one column, and the photos. And that applies to all kind of visualization. Use a grid and also try to align elements to each other. You see a simple bar chart, just because nothing is aligned, it starts looking a bit confusing and the text is moving around too much. So just find things that are clearly aligned in a way that is going to have more order. When you have an internal column grid, you are always going to make much easier to find visual variety and hierarchy in your composition. For example, that's a more kind of whimsical data visualization I did for Politico magazine, and that's using a grid. And you can see, for example, the graphics on the top left use one column, the first one, two columns, the next one. At the bottom with that Obama drawing, we have two columns and one, and then you can create a visual variety. On the right side page, we have one column, two columns, and one column. So still it stays organized because it has that internal grid, but then you can find visual variety within that structure. And that also allows you to integrate that design in a layout. For example, if you have that grids of columns for your chart that is the same as the columns in your publication, then you're going to be able to play more, integrating that design into the layout of the publication. For example, that's a chart showing US unemployment at the beginning of the COVID-19 epidemic, and see how they play with that space in the cover of the newspaper. So try to find that internal order, and the same applies to dashboards, data visualization, charts. This is something I did, and the first step always is that one. In this case, mini columns, but you can see that a lot of elements refer to that column in a way that it stays organized. Number 6, eliminate all noise, all clutter, all decoration. The data can be beautiful by itself. You don't need to try to make any ornaments, any decoration. This is an example of a map for National Geographic. If you think of this, there is nothing in this graphic that is not information. For example, I could easily make a shadow behind this map. I can have a border or an outline in the land masses. I could have boxes behind the text blocks or shadows behind those boxes under the text. But all of that is clutter. It's not information, and it just makes graphics busy and more difficult to look at. So trust your information to be beautiful without having to add any visual gimmicks. There is an idea around that from Edward Tufte. He's a Harvard professor that wrote some books on data visualization. He had this very good idea of data ink and junk ink. Junk ink is anything in a graphic that we can delete without losing information. And that junk ink should be deleted in most cases. For example, in those charts on the top, you can see some outlines, some vertical bars, or too many grid lines in the chart. That's just clutter that doesn't add anything to the information. If you remove it, you still have the same information, and it's just cleaner. So there is junk ink and there is data ink. Data ink is then the parts we cannot erase without losing information. It's the non-redundant core of a graphic, and that's hopefully, ideally, what should remain in the page. Only that. We need to use more white space. White space, and most designers always insist of that. The use of white space brings a lot of clarity. Well-organized empty space directs attention. Don't try to fill every part of your composition or your data visualization with something. Sometimes the use of white space is going to help you direct attention to different parts. White space separates, it keeps things together that belong together. So let your content breathe with space. For example, you can see National Geographic, the New York Times, very often you see these nice visualizations that are so pleasant because they have so much white space around. They become very easy to look at. They don't try to cover everything with something. So white space is very important. That's an important idea in design, invisibility. Good design disappears, just like this caption. And that means good design is the design that doesn't call attention to itself. When you don't notice that there is a design behind that information, when it stays in the background, just organizing things and bringing the important things forward, that's good design. The design that you don't really see. It's invisible, it doesn't call attention to itself. And number 9, I repeat, use a style guide. If you're going to produce data visualizations and graphics, frequently try to use, to typify, to write down exactly what type of typography you're going to use, what type of colors, because then you will be able to produce more consistent graphics and also to do them faster. So those style books are going to give us best practices with scales, with labeling, type hierarchy, and they make that production of your graphics department much more consistent. A little bit about online infographics. And this is very important. If you think about how people consume information today, most of it is through smartphones in particular. Look at that statistic. In China, there are more than 800 million people that access the internet. 98% of them are mobile users. They do that with smartphones. That means if you are going to do public outreach of any kind of information, very likely people are going to consume that information on a smartphone, not on a desktop computer, not on a tablet, not on television, on a smartphone. That's a very relevant quote from the New York Times CEO. The battle for the future of news will absolutely be won or lost on smartphones. So then they have that digital first strategy, and now it's mobile first strategy, how to present information on smartphones. However, we have not given a lot of thought about how we present infographics and data visualization on smartphones. The first important thing is our fat fingers are not helping. Whenever we tap on something on a screen, we are covering that screen with the finger. That's not ideal. And also we need to think about how people use these devices. 88% of tablet use happens while we are sitting down. Only 19% of phone use happens when we are sitting down. What does this mean? That means that typically when we are consuming information on a smartphone, we are also doing something else. We are multitasking, we are commuting, we are entering the train, we are cooking, we are doing different things. That's what we call the journalism of interruptions. You're constantly being interrupted, you're doing different things. So people that consume information on a phone need to be delivered a much simpler experience, just because the attention span is a lot shorter. There was a very influential article by Nieman Lab. It's an organization that does articles on journalism. They surveyed a lot of news organizations about how they design graphics and and interactive data visualizations for smartphones. And some ideas that came from that article are relevant about how to think about designing those graphics for smartphones. The first one there is the more important. Think of imprecise, easy to repeat motions on mobile. I think that people are often holding a smartphone with the same hand they're using to navigate. So anything that involves precision, like tapping on small parts of a screen, is not ideal either. So just scrolling vertically or swiping horizontally that are more imprecise things you can do with your thumb, those are preferred as a way to navigate through information. So take a look at that. You can loop a GIF to see change over time, break down the content into small scrollable bits. If you have a horizontal graphic that you want to adapt to smartphones, you will need to redesign that to be a vertical design. Change the orientation. Don't expect anyone to turn their phones for horizontal viewing. Only when you are watching a video, people are going to do that. Otherwise, people are going to have the phone on portrait mode. Maps are hard to do on a smaller screen. The panning and zooming can become disorienting. So you can implement search for people to locate where they are in a data visualization, or even do that in a way that is more automatic with geolocation. The device is going to know where the user is and serve information just relevant to where the user is. So those are some ideas to simplify navigation on smartphones. The ultimate tip is just save people time by reducing the number of taps and interactions they need to move through your design. It needs to be very simple. The problem with data visualization on the web is we see so many of these visualizations that where the designers use a lot of coding and technology, but they're incredibly confusing. And there is no sense of storytelling, there is no editing. The message is confusing, but just because they do these fancy visualizations that tend to confuse everybody. Right, so right now the data visualization field is basculating between that idea of the use of fancy visualization technology and also the need to edit and simplify the messages. But we see a lot of confusing data visualization like that. However, something that is very relevant in the last few years, in the last 3 years, I would say, is before you will see a lot of interactive data graphics online, we are seeing less and less of that. And that's a very, very clear trend. We are seeing more static, less interactive graphics. For example, that's a quote from Archie Seff from the New York Times. We realize the best form of database and infographics, storytelling is often static. So they are doing, these publications are doing fewer interactive graphics. And the New York Times had a presentation that explained that very well, the reasons behind that. They say, for example, that things that they used to do a lot with data visualization and graphics online are those step-by-step clickable narratives. For example, in this map, you have to click on next, 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 next. Tabs, buttons, sliders. Those are often just a way for the reader to see more content, right? The problem is that they did a lot of research and focus groups. People are not clicking on those things. That's a very, very clear trend. Whenever you have something that the reader has to click to reveal more information, a lot of people miss those things. They don't click on them. People seem to not want to interact actually too much with a screen. So readers are not getting to all the content. Readers just want to scroll and nothing else. So the easiest form of navigation, and that is universal for all devices, for desktop computers, tablets, phones, is scrolling. So news organizations, for example, are doing more and more of that presentation, where rather than interactivity, they present linear information, where you just scroll down to reveal that content. 3 rules for visual storytelling from the New York Times. If you make the reader click or do anything other than scroll, something spectacular has to happen. It needs to be worth that effort. If you make a tooltip or a mouse over, assume no one will ever see it. That's very interesting. If content is important for readers to see, don't hide it. Have it on the screen. And of course, making something interactive that works on all platforms is expensive and time-consuming. For example, that idea of you have to click on these plus buttons to reveal information, that's not a good idea, because a lot of people are just not going to do that. No matter how apparent and clear is that you have to click, many people miss those things or just don't want to click on them. So try to present all information that is relevant on the screen. So at the New York Times, for example, you may notice that more and more their visual presentations of data and maps, for example, look like this. It's a static design that is a combination of visuals and text and words. So it becomes just a scrolling, a static presentation of information rather than interactive. That's what we call scrollytelling, telling data stories that reveal themselves as user scrolls down. An example, look at these charts. This is from Good magazine. The user is mostly just going to scroll down. And you can code this page so that the scrolling itself is going to trigger most of the things happening here. And the reason why this is interesting is because then you don't need an interface. You don't need any buttons, any navigation elements. Just scroll and everything will happen. You don't need all those visual devices that are going to clutter a screen, like buttons, tabs, etc. A few years ago, a typical data visualization will look more something like this. A lot of things to click on, a lot of buttons, tabs, and at the end, the real space we have for the actual data is very small. So the trend in web design now is to get rid of all those interface elements and just do simple linear navigation by scrolling. So it's overloaded with interface elements as opposed to just scrolling, and the scrolling will trigger all that information. So in a way, that design online is resembling more and more a print page where there is no interface. It's just a clean presentation of information. And if you think of it, this trend mimics the way we use smartphones, which is just with vertical scrolling, very linear visual storytelling. The narrative and the visuals flow in a linear way from top to bottom. That's how we communicate with WhatsApp, with chat messaging applications. There is a very interesting application called Quartz that presents news as a kind of a chat with the readers. You can see on the right side, it's showing you headlines, news headlines, and it resembles a chat. You can click on next and it gives you the next headline. And then you can click on that and see and go to the website to read that particular article. So it's more and more the idea of a simple linear presentation of information. And then we have, of course, those data visualizations where we have a lot of data points. And in those cases is when we want to implement data sorting and filtering through the data. And there is a lot of value in doing that. Sometimes you have these massive data sets like this graphic showing every single shot Kobe Bryant took during his career. But even when you do that, it's a good idea to try to guide the reader a little bit. You can see here this tour the data button. So what it's going to do is it's going to present the readers with a few highlights. What are the most important parts of that data set in 5 or 6 steps? And then you can let readers explore on their own. Okay, and in that case, people can start filtering through all these shots, the one he missed, the one he made, against which different team, etc. So talking a little bit about those online dashboards, just a few very simple ideas. The idea of the grid that I mentioned before applies very well to those online data tracking dashboards. And the idea of making those modules with vertical columns and horizontal rows that can be used in a very flexible way. You can make large blocks with 2 columns, small blocks, in a way that makes the design very modular. And that is going to be very helpful for responsive design. That means on a smartphone, those cards are just going to stack on top of each other in a way that is very, very simple. So these are building blocks with a consistent structure. That's what we call cards or widgets that hold these individual charts or tables, etc. So very useful for responsive design. And you can see that the layout, the controls are very consistent. You can put the name of each card on the top left, and then the buttons or controls on the right, in a way that the users know how to work with this interface. They find everything where they expect. Very important, the same as we said about not having too many things to click on. Don't hide too much information in a dashboard. If you're going to make the user scroll too much, it's probably not a good idea. So whatever is important, show it first, and then secondary information is what you show when the user is going to scroll. And the issue of information complexity. Don't use more than 5, 6, maybe 7 pieces of information or individual cards or widget in this dashboards. It becomes too much. It becomes too complex, and it's very hard to focus on what is important here. That's an important idea. Those are the bands, the big numbers, and those get a lot of attention from users. Don't vary the most important facts in a chart. Show it as big numbers. Those get a lot of attention, and there is a lot of research saying using eye tracking software that says that those big numbers gather attention very quickly, and it's a very good idea to use them. However, remember how I said the first day that a number by itself doesn't mean anything if you're not comparing it to something to know whether it's improving, it's getting worse. So you can see in this example how we can see the big number, but also what that means. And there is some insight there by telling us this is an increase of 2.3%, for example. And some ideas that are important also are about text, how we use text in data visualization and graphics. Remember how I said that Einstein said everything should be made as simple as possible, but not simpler. The same applies to how we use text in graphics. We should have as little text as possible. So he also said text should be made as short as possible, but not shorter. Actually, that was not Einstein, that was me. that's my quote, but you can see that great minds think alike. Text should be short in data visualization, in graphics. The visuals should speak by themselves. As good graphic should stand alone. Remember, I mentioned that also, because very often people are not going to read the article or the report that chart is embedded in. But they're going to sometimes focus on the visuals. They're going to scan the page. So you should design graphics in a way that they are self-contained. They have a clear headline, an intro paragraph that makes it independent from the rest of the publication. That's a quote from Amanda Cox, a designer at the New York Times. The annotation layer is the most important thing we do in graphics. That means that careful use of labels, introductions, explanations, captions, that can make or break a data visualization because well-done captions are really going to help guide the reader through that visualization. A good idea with any kind of charts is to annotate those interesting key points so that we can call attention to the trends, to the outliers, to the important part of the visualization. This is a report from the World Bank, the Atlas of Sustainable Development, and they do that very well in this case. They have all these little captions that really provide a lot of explanation and context. It's very, very helpful to look at the charts and maps with a bit of help. So for example, whenever we see a clear change in the trend in a line graph, we should put a caption there, a note saying why this happened, why this change in the trend. So annotate your charts. And think of the role of the headline in that graphic or data visualization. Four ideas on how to approach those headlines. First, we can be just descriptive, just say what is plotted in that data visualization. For example, the US trade balance with China, 2010-2017. Another idea is to make a statement that summarizes the key message supported by the graphic. And I think that goes a bit farther. It's a bit more insightful, more telling than just a descriptive headline. The US trade deficit with China are growing larger. Then you can have another idea, a question that the graphic is trying to answer. Who wins? Or something that is what we call sticky. It's more intriguing, more enigmatic, more provoking. But that's also, you need to be very careful because that's very, very easily you can get into something that is not that funny, or so be careful with that idea. So writing for graphic is hard to do. It's often harder to do than writing long articles. I remember at the New York Times, some of the best reporters, people with Pulitzer Prizes, they could not write for graphics to save their lives. It's a very different skill set. You need to be very short, you need to be precise, you need to be non-redundant, meaning don't say what is already seen in the visual. If you see a line graph that is going up, don't say the number is increasing. We already see that. So it needs to add value to the visual. And of course, we need to have some editing constraints. For example, you see this graphic, all the text blocks in the top have the same number of lines, the same width. So have a bit of discipline editing the text so that it looks short and consistent. So those are always the same number of lines. They're short. And also think about how the reader is going to progress through that text. For example, that's a graphic we did about space missions from the Earth to different planets in the solar system. In the first version we did, which is this one, we just placed the text more or less wherever we found an empty space. And that's not a good idea. When you sketch You have to sketch where the visuals are going to be, but also where the text is going to be. Later on, we had an opportunity to redesign this graphic with new data. And then we did this other text arrangement, which makes a lot more sense. It's more linear. We have the headline and introduction on the top left, and then 3 text blocks that corresponds to 3 defined parts of the solar system. Right? So random versus more organized. So in short, always when you are sketching, think of where your text is going to be in a way that makes it organized. And a big number that I just mentioned before, a big number is a visual device by itself. Normally, the instinct normally we have is to visualize the numbers for quicker understanding, but sometimes a big number is by itself a visual device that is faster to read than a chart. For example, if you read a big 16, that reads faster than any kind of visualization. So think of that, for example, to apply that idea of the big numbers. And data visualization make us face a lot of complexity problems related to the use of typography because they have so many levels of hierarchy. Look at this one. You have headline, introduction, subheads, titles for individual charts, introduction paragraphs. You have the scale or the axis name. You have the axis numbers. You have labels. So at the end, you have 15, 20 different levels of hierarchy. And that's why it's that important that we have that very carefully done style guide to tell us how to do these different levels of hierarchy. And the same applies not just to a large visualization like the previous one, but to chart. In a very simple chart, you easily can find 6, 7, 8, 9 different levels of typographical hierarchy. Each of those need to be different, otherwise there will be confusion. So think of that, and again, with that idea of having some sort of a style guide for how you are going to use typography. Of course, the ideal graphics are those that have no text. If you can achieve this, congratulations. For example, those IKEA instructions to assemble your furniture, they don't need any words, and they work for most people. And beyond those graphs and charts, of course, we need to learn very well how to do those very simple charts, but infographics and data visualization is a field that is very, very expansive. There are many, many other ways to show information with numbers, and it's a good idea that you try to explore other ways. For example, those word clouds. That's a graphic on the left I did for the New York Times about billionaires. You can see the word cloud where the size of the typography indicates a number. On top of that, there is a cartogram. It's kind of an abstract map of the planet showing how many billionaires there are in different countries. On the right side, we have a Sankey diagram. So many ways of showing information that are not just charts, but are going to be very useful to us. Timelines. Timelines that are more relational, where we are comparing different things over time. For example, here is comparing inflation, voter turnout, unemployment, many things together on a timeline to establish comparisons. And these are all other different types of showing data that go beyond the scope of this workshop, of course. But if you are curious, try to see or to learn a little bit more about all of those. Organizational diagrams to see how an organization is structured. Data maps, that will be a workshop by itself, of course, representing geographical data with maps. Process infographics, the process of malaria, the process of extradition in Hong Kong. So those are all visual ways of showing information, and of course illustrated infographics and diagrams, and that can really engage readers at a different level, like this beautiful national infographic diagram about tuna fish. You will say, okay, but I don't know how to draw. Sometimes we have a lot of resources to make those illustrative kind of infographics. For example, that's a service I use sometimes. It's called Vector Stock. It's a stock art that you can use and combine in different ways. For example, that's a graphic I did, just combining different icons and little drawings from Vector Stock. The client gave me this assignment, but very, very short deadline. And I told them the only way I could ever do this is if I use some stock art and I recombine it in different ways. And they say, okay. So that's put together very quickly using that stock art. So that's the idea for building illustrations. If you are into the medical scientific fields, there is this website, biorender.com, that was started by a friend of mine. And they have, it's kind of a stock art for scientific diagrams. The kind of diagrams you will see in the Lancet or Nature, you can build those with stock art for those. You can see on the left side, cell structures, cell types, membranes. It's kind of scientific stock art. Think also of this idea of conceptual illustration. Sometimes our information is so complex that even doing an infographic will be too complex. For example, I remember this story. It was about desalination at National Geographic, the process of extracting salt out of the water. And the process is very technical. We thought that the infographic would be very complex. We will lose the readers. And we thought this would be much more powerful. Just a conceptual illustration showing the idea of how hard it's to get salt out of water. That's an idea that can be more powerful sometimes than a infographic or charts. And icons are also something very useful in design. Icons, even if you don't produce any charts in your report or your design, sometimes the use of those little icons are going to, as an element of graphic design, are going to make that design a lot more legible, a lot more inviting. Icons like that can be more conceptual, like the ones on the left, on how a company is going to match your 401k contributions, or more literal on the right, showing just people. So icons are a very useful device for graphic design. They are not easy to do. They look simple, but sometimes it's hard to come up with ideas for these abstract concepts. The idea of these icons derives or comes from Otto Neurath. He was a neuropsychologist in Switzerland. And he came up along with Gerd Arndt, who was an illustrator, with that idea of using little icons to display statistics. For example, imagine a chart that instead of a bar is made of a row of factories or workers. So that idea of icons applied to charts come from there. All right, do you guys have any questions? We can make a quick pause before we look at these exercises, the COVID-19. No? Okay. All right, so I have to say I only received 3 exercises for the COVID graphic, which is fine. I think maybe I was a bit short-sighted to pretend that people who are busy will be spending time on this, but they're nice. They're nice. For example, one of I'm not going to give names or anything. I think they're all nice. Someone used Tableau, which is great. That's very nice software for visualization. And this is showing how different regions compare in the number of active cases for COVID. That's always a good idea. And you can see very clearly the trend. It's not so much of a dashboard because it's not combining multiple things, but it's nice. What I will say here is always be mindful of that difference between actual number of cases versus grades. If we are talking about different regions, sometimes it makes more sense a number of cases per 100,000 people or number of something per capita, because that's a way of making things comparable. What I mean is the line on the top here is higher, possibly because this province or region has more population. So it doesn't mean that the problem is worse there. So,
hey Juan.
Hi.
Sorry to interrupt. So when I did this graph, what I wanted to do was I wanted to have a line down the middle that actually represented the cutoff line for when a city goes into lockdown. But I couldn't find, there was no information stating if a city has this many cases, then they go into lockdown. So I think I realized then that it's not simply based on how many active cases determine whether or not a city goes onto lockdown, because like the green line, the one right above where I put my cursor saying that's the city of Hamilton, is York region. And I know a lot of people were mad that York region wasn't going into lockdown when Mississauga and Toronto was. So I was going to show like, you know, how unclear it's been, like who goes into lockdown and who doesn't. But I couldn't get a hold of that information.
Yeah, no, and you didn't have time, of course. And yeah, there are other things that are factored in, like the positivity rate, what percentage of people test positive when they take a test. Also, look at this scale on the left side. That's a logarithmic scale. The increments are not even. For example, we see 500, 1,000, 2,000. Which is fine and is used a lot in scientific visualization, and that's something I mentioned the first day. But that catches many people by surprise. Most users don't expect that type of scale, right? So just if we are doing that, we need to at least mention it very clearly that we are using that type of scale. They can be useful sometimes because it allows you to see differences in the small values as well as in the large values, but just mention it. This was a nice 3-page or three elements graphic, really nice effort. And what I like the most about this is that very first part showing the little people and that those shocking percentages of the probability of contagion. You can see how introducing those little icons with faces already makes the story a bit more inviting, right? And the idea of refer to actual people or to makes it relatable. The last part, 3, you can see at the bottom left, is also nice. Also some takeaways, some practical advice, or something that makes it also relatable. The chart on the right is very interesting, and it's showing that that idea of uncertainty that is used always in scientific diagrams, the 90% confidence interval, 70%. And I will say that this will depend on what publication you're going to use this graphic. So I think what is showing is the number of observed cases with the black dots, and then what will have happened with no implementation of any policies to stop the pandemic, and the blue line is the actual policies implemented. So it's a very nice, very relevant comparison. Those interval confidence brackets or shaded areas for a major publication for a general audience, most typically we would take those out because there is in many cases there is always going to be that uncertainty, but they tend to clutter the design and not be relevant enough to be worth it. for most people. Of course, in scientific publications, we do need that kind of visualization of uncertainty, but I would say depending on the audience of this, not so much, but it's a very clever visualization. I like this a lot. And this was a sketch about COVID in Brazil that I think it has all the right things. It's simple, it has the big numbers, it has the total number of cases. It has the ratio or the percent change that makes regions more comparable in that map. So population percentage as opposed to population totals. That's always going to be a good idea. And even it has that funny element at the bottom. I thought those were pies in perspective, pie charts, but those are actually soccer stadiums, which are a nice way of looking at how many people died. And of course, in Brazil, soccer is everything. So that's a very good way of showing that information. That's nice. That's a nice sketch. Those are more like the kind of dashboard that I meant, with 5 or 6 or 7 different modules that are what we normally call a dashboard. So some ideas to remember. The total number sometimes is not very meaningful. When we have variables like time and population, for example, this cumulative number of cases in the US, by the time this was published, New York was not a problem at all. So that's not very meaningful for readers. We need to normalize that data. When we track change over time or over populations, it's sometimes a good idea to eliminate the actual units and to use a notionally common scale. That means percent change, and that makes data more timely, more relevant. How this information is changing now in the last week or 2 weeks. Or calculating rates to make different regions or states or counties more comparable by using that kind of unit. For example, cases per capita, per 100,000 people, etc., in a way that makes those populated and less populated areas comparable. So that's very, very important.
Juan,
yeah.
There's a question in the chat about if you wanted to make visualizations with maps like this, are there, is there a particular platform or tool other than, Python or R that is available that's kind of recommended or the easiest to use if you are interested in doing maps?
Yeah, there are many tools. You don't need to use coding to make online interactive maps. You can use, for example, you can use Tableau, you can use Flourish, Data Wrapper. Actually, the 3 that were shown in that video I sent you, those are great for mapping. Flourish and Data Wrapper a bit more than Tableau, because Tableau doesn't handle very well map projections. They only use that web Mercator projection that is not the best, for example, to use to show the US. But if you give Data Wrapper a try, you can build a map like this super easily, very, very easily.
Juan, would you be
Yes.
using like GeoJSON data to make maps with Data Wrapper or Flourish?
You can, yeah, you can import GeoJSON files, definitely.
Okay.
Yeah, you can import shape files, GeoJSON, and it has a built-in database of geographic divisions, meaning you can find a map of the US by county, by congressional districts. You can find Canada maps by different types of divisions. So those are very, very useful. All right, so another couple of very nice ways of representing this information. Small multiples, showing also how the COVID is evolving in different parts of the US. And remember that idea, showing the near and the far. Something I mentioned the first day, show the national picture, like on the left, but also the small picture. That's something that is the more concerning picture for the reader, right? The local story. And that's the county where I live in the US. So I look at this chart often. You need to tell those 2 levels of storytelling. John Hopkins University, they used to have this very complex dashboard with a lot of graphics and metrics. And I was surprised the other day to see that now they're doing something different. The first thing you see on the website is an animated graphic showing the main statistics. Let me show you. So it's interesting that they recognize that more and more people consume information through social media. That video is on Facebook. And then they just want a quick snapshot. They don't want to look at a complex dashboard with a lot of numbers. And we're in that culture of video. More and more animation that people will find on social media. In my company, we do animations because that's what clients are asking for, right? And those quick visual presentations. And that's very simple to make, actually. For example, using Adobe After Effects, which is animation software, you can build that in a relatively simple way. So it's not too complex to learn.
Juan, there was another question in the chat. Someone, Nina, she tried the election exercise from the instructional video with the data set, and Tableau didn't recognize the locations. And so she was wondering, if that was the format of the file, or what was causing that, or if you have kind of general tips of the best way to troubleshoot or find help when you're doing these types of things.
Yeah, that in Tableau that happened because you guys are in Canada, right? So by default, it's trying to try to read the names of those counties as Canadian locations, and it will not find them. Yeah, I forgot to mention that. So you just need to go to the top menu in Tableau, where it says map, and then you go to edit locations, and just specify these are United States locations, and then the information will pop up. So it's trying to, by default, see those county names as Canadian locations. You just need to reassign the geographic attribute. Yeah, sorry about that.
Thanks. No, Canadians are used to these types of issues being so close to the US, I think.
All right, so just as some resources, these are the 3 applications I show in that video, because I think they are the best and the more useful when you want to make relatively simple interactive data visualization, including data maps. Tableau, Data Wrapper, and Flourish. Tableau goes much farther in terms of depth. It's a very analytical tool for very complex data, if you want to take it that way. But also you can do very simple things with it, simple charts, simple maps. And Flourish and Data Wrapper were created originally for news organizations where they need to produce a lot of charts and maps quickly with a simple, clean design. They're very useful, unless you're making a very, very complex type of graphic. Give them a try, because they're easy to use for people that don't want to get into coding, into programming. Regarding books, I recommend all of Alberto Cairo's books. I think they're great. These are very good primers for information graphics and data visualization. The functional art, the truthful art, and the last one, how charts lie, how we can get deceived by charts whenever the the people creating those charts have some sort of bias. This one on the left is very useful for chart design. The Wall Street Journal Guide to Information Graphics. That's kind of an expanded version of those do's and don'ts I gave you the other day. Is how to use scales, how to not make errors in the design of charts. Very, very practical short book. The one on the right just came out, Better Data Visualizations. That's also a very nice book, very comprehensive, all the different types of charts, when to use them. I just bought this book and it's really excellent. I really recommend. And something that is a bit different, but a really nice book that came out recently is called Calling Bullshit, and the Art of Skepticism in a Data-Driven World. Also about how many times we are deceived by these visual representations of data, and how to deal with that, how to get a bit more literacy in using this type of visualizations. They are two professors at the University of Washington. These are very nice blogs and websites that to follow. The functional artist Alberto Cairo's blog. So that's a list. Remember, I will send you this presentation after we finish. Podcasts about data visualization, inspiration to see nice examples of graphics at the bottom. The New York Times, the South China Morning Post. Those are all great organizations making very good graphics. So take a look at that. Those are nice Twitter accounts to follow. Mine goes first, of course. And then there are the good ones. And below that, you can see very nice Twitter feeds from news organizations. And on the right side, from different people doing great work.
There was a question also in the chat about Power BI as a tool. Are you familiar with that one? How does it compare to the Data Wrapper and the other ones you've mentioned?
I have never used it. That's the Microsoft data visualization tool. That's more comparable to Tableau, probably, right? That's when you want to go deeper into analyzing data or doing things that involve really large data set. For practical purposes, and if your graphic is or map is not too complex, I will go with Data Wrapper or Flourish, I would say. But I have never used Power BI. This is a list of books. Some of the best books on data visualization, data graphics, maps, visual perception, etc. So take a look later on. This is my own website. If you want to take a look, there is a blog. And I also host a workshop for infographics and data visualization that maybe if you want to take a look, it's a longer workshop. It's over 4 different sessions, 3 hours each. And that's all. As part of this material I'm going to send you, there is that additional presentation that I think is fairly self-explanatory. It's also about different tools for data visualization. Some of the most sophisticated types of graphics online need coding or need the use of GIS software for mapping, but those are more complex to learn. So here I mentioned those as well as those that are easier to use for non-coders.